This one we're going to start by finding the domain. So again, you're going to want to take whatever's on the inside of the logarithm, so this x minus 7, and set it greater than 0. Solve for x. So x is going to end up being greater than positive 7. Transformations, that 1/3 that's out in front is going to be a vertical compression. By 1/3. The minus 7 that's on the inside is going to shift it to the right 7, which is why our domain is everything greater than 7 rather than greater than 0, which is what the domain of the parent logarithm function is. And last but not least, this plus 2 is going to move everything up 2. To find the inverse, which is what we need to do next, I would recommend rewriting the original problem. So 1/3 log x minus 7 plus 2, and set it equal to y with the y on the right side. I find that for one of the steps we have to do in the next couple rounds, it's a little bit easier if the y is on the right side. So for starters, anytime you find the inverse, the first thing you have to do is switch the x and the y variable. So that's what I'm going to begin by doing. So all I've done so far is switch x and y. All right, now, remember, our goal is to try to get this y by itself. And we can't get that y by itself until the log is gone. And we can't get rid of the log until the 1/3 is gone and the plus 2. So we're going to start by kind of whittling our way down to try to get at that y by starting by subtracting 2 from both sides. So 1/3 log y minus 7 is going to equal x minus 2. And then the next thing we need to do is get rid of that 1/3. So the 1/3 we can easily get rid of by multiplying both sides by 3. You can technically divide by 1/3, but that's going to make the right side kind of a mess, so I wouldn't recommend doing that. So I'm going to put the 3 over here as well. So what we're left with on the left is a log with y minus 7. And on the right, you can choose to leave it as 3 times x minus 2 if you like. Or I'm just going to go ahead and distribute it. There's no reason not to. So write it as 3x minus 6. Now, we're trying to get at this y inside of the logarithm. Now that the logarithm is isolated, there's nothing around it being multiplied or added or subtracted on the end. Now this is where we're going to use the relationship between logs and exponentials. So the base of this logarithm, this common logarithm, is 10. So 10 is going to be the base of your exponential. This 3x minus 6 is going to be your exponent. And then it's going to equal y minus 7. And the last thing you have to do to get y by itself is just add 7 to both sides. Now make sure whenever you do these last couple steps, whether you have to multiply, add, subtract, divide, whatever the case may be, this piece here is going to remain unchanged. So by adding the 7 to the other side, it doesn't all of a sudden make this base 17. That base is going to remain 10 no matter what. The exponent's not going to change. I'm just going to put that plus 7 after it. All right. So that's our inverse. The last part of this is really just us trying to get you to check your work. And it says graph the inverse in your calculator along with the original function. So our original function, if we go back to the beginning, was this 1/3 log. All right, so I'm going to go into my y equals menu. 1/3 log of x minus 7 in parentheses, and then plus 2 on the end. Okay. All right, and you can graph that if you like. It doesn't look like much because it's way over to the left or to the right. But I'm going to go ahead and type in my inverse. So 10 raised to the 3x minus 6, and then, what was it, plus 7 on the end, I think. And I'm going to go ahead and draw on the line y equals x. And it should look like they reflect over that line. And this one's kind of hard to tell because, unfortunately, calculators are limited with what they can draw. And what should be happening over here, even though you don't see it, is this graph should be going down like this. So if the graph is a little hard to read, what I would recommend you do is go into your table and look for a couple key points. So I'm actually going to go out and I'm going to turn this one off. I'm going to turn the inverse off, and I'm going to get rid of this y equals x. So when I graph it, the only thing that's going to be shown is the logarithm, and kind of try to pinpoint some points. Like, for example, 8, 2. Try to find any integer points that you can. So because the point 8, 2 is on the logarithm, when I graph the exponential, I should find the point 2, 8. Yep, there it is. So it's going to be, checking a lot of points on this isn't realistic, but if you can even just find one point where, like in this case, we had the point 8, 2 on our graph. And then for our exponential, we ended up with the point, our inverse graph, we had the point 2, 8. That's a good check if visually, if you're not sure whether or not the functions you got were inverses of one another.